Okay, this equation right here shows the mathematical relationship between the pressure and the volume of a gas. We call that relationship Boyle's law. So any gas has a certain initial conditions. It's at a certain pressure and it has a certain volume. If you make a change to one of those two things, either to the pressure or to the volume, so for example here, if you decrease the volume, that's also going to change the pressure. So here's our equation, here's our problem. Let's read that and solve it. In Boyle's law, because we're manipulating pressure and volume, we are assuming that temperature is held constant, as is number of molecules. So that means you're not adding more molecules into or out of the container. All right, the problem says a sealed container has a volume of 1.5 liters and a pressure of 98 kilopascals. The volume is decreased to 0.75 liters. What's the new pressure? Notice the units. Whatever your units are for pressure or for volume, it doesn't really matter as long as they stay consistent. So our volume units right here are liters, volume units stay liters. Our pressure units are kilopascals, so when we solve for the new pressure, our pressure units are going to be kilopascals. That's because those volume units, in this case, are actually going to cancel out. So as long as they were the same thing, that's okay. All right, so a sealed container has a volume of 1.5 liters. That is our volume 1 at a pressure of 98 kilopascals. That's our pressure 1. The volume is decreased, so a change happens to 0.75 liters, so that's our volume 2. So let's list our givens. Volume 1 is 1.5 liters. Pressure 1 is 98 kilopascals. Volume 2 is 0.75 liters. Pressure 2, what is the new pressure? That's what we're solving for. The equation we're going to use, P1 V1 equals P2 V2. Pressure and volume multiplied by each other at one condition is equal to the pressure times the volume multiplied by each other after a change has occurred. Plug these givens into that equation. Pressure 1 is 98 kilopascals times volume is 1.5 liters equals pressure 2 is what we're trying to solve for times volume 2 is 0.75 liters. Okay, a couple different things I could do here. I could multiply these together first. If you want to do that, go for it. I'm first going to get my P2, my unknown, by itself. It's being multiplied by 0.75 liters, so I need to divide it by 0.75 liters, which means it's gonna, all of that's going to cancel off of that side. And if I divide that side by 0.75 liters, I have to do it to this side, 0.75 liters. Look at our units. Liters on the top, liters on the bottom, which means those units are going to cancel, which makes sense because our answer, which we're solving for pressure, so our answer is going to be in kilopascals, which is a unit for pressure. So let's plug and chug. 98 times 1.5 divided by 0.75 gives me a pressure of 196 kilopascals. Okay, then think about whether that makes sense. So what happened to the volume? The volume decreased. It halved. It went from 1.5 to 0.75. So what do we know about Boyle's law? If the volume decreases, like this picture, well, if the volume decreases, what's going to happen to the pressure? The pressure should increase because you have the same amount of gas and half the amount of space. So if the volume decreases, the pressure should increase. This is an inverse relationship. Is that what we see happen here? Volume decreased and then pressure increased. The pressure doubled. It went from 98 to 196 kilopascals. So that's good. It makes sense. All right, next, that was Boyle's law. Next one is Charles's law. A note on Charles's law, your temperatures have to be in Kelvin. So if you get a problem and it lists the temperatures in Celsius, degrees Celsius, you need to change them to Kelvin. That's your equation to do that. Whatever it is in Celsius, plus 273 gives you your temp in Kelvin. That's because we need to make sure that we have all numbers above 0. No negative numbers here or it's going to mess up our math. So Charles's law, here's the equation. Volume 1 over temp 1 equals volume 2 over temp 2. So this is the mathematical relationship between the volume and temperature of a gas. So the volume divided by the temp of a gas at a certain condition, make a change, is going to be equal to the volume, the new volume divided by the new temperature of the gas after that change happens. Charles's law assumes that the pressure is held constant and that the number of molecules are held constant. So let's read our problem. Sealed container has a volume of 2 liters at 300 Kelvin. The new temperature decreases to 230 Kelvin. What's the new volume? So first check, our temps are in Kelvin, so that's good. We don't need to do anything with that. So let's look at our givens now. Sealed container has a volume of 2 liters. 2 liters, that's a volume. It's our initial volume, or volume 1, at 300 Kelvin. That's a temp, so it's going to be temp 1. The temperature decreases, so after a change, so T2 is 230. New volume is what we're solving for. So volume 1 equals 2 liters. Temp 1 equals 300 Kelvin. Temp 2 is 230 Kelvin. Volume 2 is what we're solving for. So, and again, just like Boyle's law, your units here are going to cancel out, so as long as your units for temperature, well, your units have to be Kelvin for temperature, but whatever your units are for volume, if they were, for example, milliliters and milliliters, that's fine as long as they're consistent. Here's our equation. Let's plug the givens into that equation. V2s are unknown. Now we're going to cross multiply these because we need to get V2 on its own. So we've got this proportion set up, so we're going to multiply 2 liters times 230 and 300 times V2. So 2 times 230 is going to give me 460 equals 300 times V2. Still need to get V2 on its own. It's being multiplied by 300, so I'm going to divide by 300, which is going to get rid of that. And if I do it to that side, I have to do it to this side. So 460 divided by 300 is 1.53. My answer is going to be in liters because that's what my initial volume was. So again, let's think about whether or not this makes sense. What happened to the temperature? The temperature decreased. So if the temperature decreased, what do we know about what happens with volume and temperature? If we decrease the temperature, so if you take your balloon outside in the wintertime where it's cold, that balloon is going to shrink, so your volume is also going to decrease. That's called a direct relationship. That is, one thing goes down, the other thing goes down, or as one thing goes up, the other thing goes up. So is that what happened? Our temperature decreased, our volume went from 2 to 1.5 or 1.53 liters. So yes, temp went down, volume went down. So that makes sense, that checks out.